Hey y'all, Mr. Kowalczyk here. Sorry I couldn't be here today. I had to run out and do an errand that was super important I couldn't get out of. So I will see you. I'll be available for any extra help. I have first, third, and fifth off on Wednesday. And I also have access time Thursday morning. So if anybody needs any help, come holler at me in your preparations for the test or trying to understand this particular section. Mr. Youngren is going to cover for me today. So if you do have any questions, he might be able to help you out. All right, so for Unit 12, area and volume of solids, we got our last section for today, 12.5, area and volume of similar solids. Now, this is very, very much like the lesson we did in the last chapter, where we had the ratios of the perimeters and the areas. So we're going to be building on that, except now we're in 3 dimensions instead of 2 like we had in Unit 11. All right, let's go ahead and jump in. So first slide, we're going to be comparing similar solids. You may have taken notes on this already. If so, great. If not, please follow along. The ratio of the corresponding lengths is A to B. So the scale factor is going to be the most important part. So scale factor, which is A to B, is most important. Okay, so starting off with a known scale factor of A to B, because that's what we're going to be really, it's going to help us out a ton. All right, so now we've got the corresponding lengths being A to B. So if the ratio of 1 to the ratio of 2, that's going to be equal, excuse me, the radius of 1 to the radius of 2, that's going to equal A to B. Yeah? So then what we're also going to consider is that the slant height of 1 is equal to the slant height of 2, or compared to 2. That's also the same as A to B. We have the height of the first and the height of the second. They're similar figures. That's also A to B. So you're noticing lengths are all the same as the scale factor here, right? If we have the P of 1 to the P of 2, that's going to be A to B, perimeter. If we have the circumference of 1 to the circumference of 2, that's a length. That's also going to be A to B. So anytime we're talking about length, that's going to be the scale factor. Okay? It's equal to it, the ratio. Now the area, as we learned last chapter, is going to be A squared to B squared. So that could be surface area of 1 to surface area of 2. It could be A squared to B squared, right? We take the scale factor and we square it to get that. Okay, a couple of you mixed that up on the test, so try to make sure that you got it now. The lateral area of 1 to the lateral area of 2, that's going to be A squared to B squared, the scale factor squared. And then what's the other one? Oh, base area, right? Base area of 1 to base area of 2, that's going to be equal to A squared to B squared. Okay, scale of the square factor for area. And just because now we're in 3 dimensions, we cube the scale factor to get to volume. Okay, so that's going to be cubed to get from one to the other. So the volume of 1 to the volume of 2 is equal to the scale factor cubed, both A and B cubed. Okay, this is the main idea for today. Let's put this into practice here. Now, we got some true or falses. Go ahead, pause the video, talk to your neighbors and friends, see if you can solve these on your own. All right. First off, all spheres are similar. Is that true or false? That is true. Okay. Only the radius changes. So if that changes, the whole sphere does. Whole sphere changes similarly. Yeah. all right cylinders are similar, true or false? Well, that one's going to be false. Okay, so we have a counterexample. You might be thinking of something like this, where if we have something tall and skinny, as opposed to, you got a right cylinder here, right, where the height is perpendicular to the base, something that is short and wide. These are definitely not similar. We can't just scale up the radius and get a similar shape, okay? The radius has a different scale factor than the height, so that's definitely not going to work. All cubes are similar. That is true. The reason why that's true is because all the lengths are the same. So if you scale up the length, it's going to be similar to the circle in that the whole cube is going to increase or decrease in size, okay, in a similar scale factor. Finally, two cones have base radii 9 and 12 meters, heights 12 and 18 meters respectively. The cones are similar. All right, well, let's check it out here. You know how I am. I love visualizing stuff, so I'm going to sketch these out. All right, so that'll be our big one. And this will be our smaller one. Okay, so the radii is 9 here. And this is going to be 12. Now I need to pay attention here because the first 9, the first radii that's listed, and the second radii that's listed here, we're going to call this cone 1 and this cone 2. All right, so we have to pay attention to this as well. So the height here is going to be 12 because that's our first one listed. When it says respectively, it means the order matters. Okay, this is going to be 2 for the second cone, and this is, so that's going to be 18. The cones are similar. Well, let's check it out. We have to make sure that the height and base have the same scale factor as they increase. So 9 compares to 12 as 9 compares to 12 as 12 compares to 18. Now I could solve this a couple different ways. I could reduce my fractions or I could cross multiply. Let's do both and see if it works out. So 9/12, that has a common factor of 3. So that's going to be 3 over 4. 12 and 18 have a common factor of 6. So that's going to be 2 over 3. So that shows us that they're not similar because they don't have the same scale factor. Let's cross multiply and see what we get. Well, 12 times 12 equals 9 times 18. Does it equal? I know 12 times 12 is 144. I'm going to use my handy dandy adding machine here. 9 times 18 is 162. Okay, so that disproves their similarity as well as the fact that they don't have the same scale factor. No, so that is false. Okay, all right, let's move on. First practice problem here. Two similar cylinders have circumferences of 18 centimeters and 18 pi centimeters and 24 pi centimeters. What is the ratio of their volumes? All right, so now we're doing volumes, so we need to pay attention to that. We've got circumferences and we're trying to solve for volumes. Okay, so going back to our original scale factor of A to B, and then so this is our scale factor. Our volume factor is going to be A cubed over B cubed. All right, pause the video, see if you can go ahead and solve this. Okay, now let's jump in with the scale factor. Okay, scale factor is length. And why is that important? Well, because we're dealing with circumference, and circumference is a form of length. So, I'm sorry I wrote this like a fraction. I didn't mean to write it like a fraction. I just wrote scale factor underlined with length underneath it. Don't see that as a ratio. So the scale factor is going to be A over B, which is going to equal circumference of 1 over circumference of 2. So that's going to equal 18 pi over 24 pi, right? Now this is going to reduce, and then 18 over 24 have a common factor of 6, and that becomes 3 over 4. So my scale factor is going to equal 3/4. Awesome. Now I have to use my rule up here to get to the volume factor. So that means 3 cubed over 4 cubed is equal to my volume factor. Well, that's 27 over 64, and that's going to be my volume factor, right? Awesome. Okay. So what is the ratio of their volumes? That's the volume factor. The ratio of their volumes is the volume factor, and I am done. So the ratio of the smaller volume is 27 to 64 for the big. That's all there is to it. All right, let's try the next one. Two similar square pyramids have base areas 4 meters squared and 36 meters squared. Find the ratio of the heights of the pyramids. And number 2, if the height of the larger pyramid is 27 meters, what is the height of the smaller pyramid? All right, pause the video and see if you can tackle this one. Okay. Two similar cones have volumes of 16 inches cubed. Sorry, that's the next one. Jumped ahead. All right. So now the square pyramids have base areas. And what we're trying to do is find the ratio of the heights of the pyramids. So my area factor, as I remembered, is a squared over b squared. And the ratio of the heights, that's length, that's going to be a to b. So I have to remember what I'm working with. I need to go from a squared to a not squared, okay? So what that tells me is that a squared over b squared is equal to the base area of 1 over the base area of 2. All right, so what does that equal? That equals 4 to 36. Now this is my area factor. And you might be tempted to say, all right, cool. How does that play into my scale factor? You also might be tempted to look at this and say 4 over 36, well, I can reduce that to 2 over 18. You could, but it would make the problem more annoying. The reason why is that to go from the area factor to the scale factor, you need to go from a squared over b squared to a over b. And how do we do that? Obviously, we square root. So if we take the square root of 4 and the square root of 36, that's going to give us a over b equaling 2 over 6. Now, why is that important to not reduce this fraction? Obviously, because 4 and 36 are both perfect squares, it makes it easier to then go and solve to take the square root of both. 2 to 6. Now we can reduce this to our final scale factor of 1/3. Okay, so that is our scale factor, which is also the ratio of the heights, because height is a length. So our final answer for this problem, the first part would be 1/3, right? Or we can see it, consider it the height 1 over the height 2 equals a over b, which is our scale factor, which is 1/3. That's helpful to see it that way also. All right, now the second one says if the height of the larger pyramid is 27 meters, what is the height of the smaller pyramid? Now I'm going to length, which is equal to scale factor, and I'm staying with height. So that's also length, which is equal to scale factor. So I don't have to mess around with changing the area factor, the volume factor, or any of that stuff, okay? So the height of 1 over the height of 2, that we know that that's going to equal 1/3, because that's our scale factor from the previous problem. Now, how do we set this up into a ratio? Well, we know that the height of the larger pyramid is 27. So as I set this up in another ratio, I know that 1/3 is going to equal the height of the smaller pyramid divided by the height of the larger pyramid, which is 27 meters. Okay. Now all I need to do is cross multiply, and I get 3x equals 27, and x equals h1, which equals 9 meters. And we're done. Okay. All right, last problem for today. Two similar cones have volumes of 16 inches cubed and 54 inches. Okay, so we have volume. So I'm going to remember that means A cubed over B cubed of 16 inches cubed and 54 inches cubed. If the slant height of the smaller cone is 8 inches, what is the slant height of the larger one? Slant height is going to be scale factor, which is a length, which is A over B. I'm just making notes, reminding myself what I need to do when I'm solving this. Okay. All right, so I know the volume factor. So the volume factor, which is volume 1 to volume 2, which is equal to A cubed over B cubed, is equal to is equal to 16 over 54. Okay. So now what I need to do from there, that's my volume factor. I need to go ahead and transition that into the scale factor. So how do I take the cube root of each of these? Well, I write it like this. Yeah. Okay. So let's go ahead and play with this. Please remember, if we do the cube root of 16, we can break that down and we do the same thing that we've been doing all along. So we know this is 4 and 4. And then we know that 4 and 4 break up into 2 times 2 times 2 times 2. Now, when I'm finding the cube root, what I'm looking for is groups of 3 of these things. And I've got 3 of those right there. 2 times 2 times 2 is 8 times 2 is 16. So now what that does is it gives me, since there's 3 of these, that tells me that I can take out a perfect cube, which I take 3 of these, it turns into 1, 2, and I'm left with the cube root of 2, which is this remaining one right there. So the cube root of 16 is equal to 2 cube root of 2. And we do the same process for the cube root of 54. And that's going to break down into 2 times 27. And then 27 breaks down into 9 times 3, which also breaks down into 3 times 3. So here I've got my 3 3s, and I'm left with a 2. So that's going to break down into, these 3 3s break down into a normal 3. And I have left over, I have the cube root of 2. Okay, now stay with me on this one. This ratio simplifies when I take the cube root to get to my scale factor. It equals 2 times the cube root of 2 over 3 times the cube root of 2. And just like we do with square roots, the cube root of 2 over the cube root of 2 can be reduced to 1 over 1, and that equals 2 over 3. So since we took the cube root of our volume factor, that gets us to our scale factor. So now we have our scale factor. We took our cube root, and then the height of the smaller cone is 8 inches. So smaller is going to go on top because that's 2 over 3. So now we set up our proportion. 2 over 3 equals 8 over H2. Okay, cross multiply. 24 equals 2H2 divided by 2. H2 equals 12. Oh, sorry. We're done. All right, last slide for today. Well, second to last slide. This is our formulae so far, okay? If you want to add on to this, you can. Remember, scale factor is equal to A over B. Area factor is equal to A squared over B squared. And volume factor, which we now know, is equal to A cubed over B cubed. If that's helpful for you, go ahead and pop that into your formula sheet. All right, you can pause this, take notes on it, whatever. This is our last slide for today. Okay, now, this is the right one. Okay, so just a reminder, when you're studying for the test, okay, you want to redo any questions, absolutely come and ask me for help. Because you've gotten your quizzes back, I can give those to you. The practice test, which is in Schoology, you've got chapter test on 519 and the chapter review on 518. Your answers are in Schoology as well. Again, pause this, take a picture of it, come back to it, whatever you need to do in order to study for the test, which is on block day. Okay. All right, y'all. Hope this was helpful. Check in with Mr. Younger if you have any questions. Otherwise, I will see you when I see you.